Welcome! In this explainer, we are tackling one of the absolute biggest questions you can ask. Where did all of this, the entire universe, come from? We're going to explore a really mind-bending idea that the answer isn't something, but, well, absolutely nothing.
So let's start with this classic puzzle. For centuries, it seemed like simple logic. If the universe had a beginning, it had to have a beginner, right? But that just kicks the can down the road. It pushes the question back one step, and you get stuck in this endless, frustrating loop.
And that brings us to our first section, what we're calling the creator paradox. The problem here isn't just that it's a tricky question. It's a fundamental, logical trap that has stumped philosophers and scientists for ages. This whole mess is known as infinite regress. See, every cause has to have a prior cause, which needs its own cause, and on and on and on, forever, with no logical starting point. Even early science, with the Big Bang theory, still had to wrestle with this. Okay, so there was a Big Bang, but what banged the bang? What came before that first moment?
Okay, but what if there's another way to look at this? Let's see how modern physics is offering up a really radical solution. What if the universe didn't need any startup energy at all? What if it's running on a perfectly balanced budget?
So this is the core idea. It's called the zero-energy universe hypothesis. And what it suggests is that the cosmos isn't some miracle of something popping out of nothing. Instead, it might just be a perfectly balanced equation that is always and will always equal zero.
The easiest way to think about this is like a bank account. Let's say you have $5 in your pocket. That's positive. But you also owe your friend $5. That's a negative, a debt. So what's your total net worth? It's zero. The universe, believe it or not, might be playing that exact same game.
This table really lays it all out beautifully. You got mass energy, all the stuff we can see, all the stars and galaxies. That's the positive side of the ledger. But then you have gravity, which acts as a kind of binding energy, and it's negative. It's the cosmic debt. And when you add the assets and the debts together, the total is zero, perfectly balanced.
And this is the core concept right here. The very act of having matter, that positive energy, automatically creates a gravitational debt. So, the more stuff there is, the more negative gravitational energy there is to perfectly cancel it out, keeping the total locked right at zero. It's an incredible idea.
So you see, the really crucial point here is that this whole thing sidesteps the problem completely. The universe didn't have to break any laws of physics to be created. It's more like nothing just separated itself into two equal and opposite parts that we now perceive as something.
Now this is where it gets really wild. Let's pivot from hard physics to ancient philosophy for a moment, because this cutting-edge scientific idea of a universe born from a balanced zero, well, it has a startlingly similar echo in wisdom from thousands of years ago.
Really think about that for a second. What if this isn't some brand new revelation? Could it be that ancient thinkers using introspection and metaphysics actually got to the same conclusion our physicists are now reaching with complex mathematics?
Let's look at Indian philosophy, specifically the concepts of Shiva and Shakti. Shiva isn't a person here, but a principle, the static, unmanifest potential of the universe. It's the silent witness, the potential of nothing. And Shakti? Shakti is the exact opposite. It's the dynamic, creative, energetic force that brings everything into being. One is potential, the other is action.
Now this slide, for me, is the heart of this entire explainer. Just look at these parallels. The unmanifest nullity of Shiva lines up beautifully with the modern concept of the quantum ground state, or maybe even the vast, invisible web of dark matter. And Shakti, the manifest energy, well, that's like all the visible matter and the expansive force of dark energy. And their interaction, their cosmic dance, that's the Big Bang. That's the universe expanding. It's uncanny.
So for our final section, let's look at how a perfect zero can actually give rise to this incredibly rich and complex universe we live in. Because, let's be honest, a state of perfect balance sounds kind of sterile, a little boring.
Yeah, if the universe just stayed in that state of perfect symmetric nothingness, nothing would ever happen. It would be completely featureless. So the very fact that we exist, that there are stars and galaxies and us, is proof that this perfect initial symmetry had to break somehow.
Now don't worry, you don't need to understand the math here. The point of showing you this equation is just to illustrate that this idea of a zero-sum universe isn't just a philosophical handwave. It has a real, rigorous, mathematical foundation in physics. It's a formal way of saying it all adds up to nothing.
So how does that perfect symmetry break? This is probably the best analogy for it. Imagine a ball balanced right on the tippy top of a very sharp peak. That position is perfectly symmetrical, but it's also incredibly unstable. The tiniest little nudge will send it rolling down one side of the peak into the valley below. The moment it starts rolling, that perfect symmetry is broken, and a specific reality, our universe, gets chosen.
Okay, this leads us to the final piece of the puzzle. If the universe started from zero and will end at zero, what does that mean for its beginning and its ultimate fate? Does it have a hard start and a hard stop?
Well, the brilliant physicist Sir Roger Penrose came up with a theory that is just mind-blowing. It's called conformal cyclic cosmology, and it suggests that the universe goes through these immense cycles, or eons. Each one starts with a Big Bang, then it expands for trillions of years until everything is cold and dark and only massless radiation is left. At that point, concepts like time and distance become totally meaningless. And here's the kicker. That infinitely large, cold future becomes mathematically identical to the infinitely small, hot point of a new Big Bang. The end of one universe is the beginning of the next. It's an endless cycle.
And this quote just brings it all home so perfectly. The something that is our universe didn't come from some external place or being. It came from the absolute, inherent potential that was already locked inside that initial zero state, a nothingness that somehow contained the seeds of absolutely everything.
So I'll leave you with this final thought to chew on. If the cosmos is a completely self-contained, zero-sum game, and if our existence is thanks to a tiny break in that perfect symmetry, then maybe our consciousness isn't just some random accident. Maybe we are the universe itself finding a way to observe its own incredible, magnificent unfolding.